Okay, so this is 1992, question 6C, and we're looking at the polynomial 1 plus n on 1 x plus n on 2 x squared, and that pattern continues up to n on n x to the n. And that's the expansion of 1 plus x all to the n. So we looked at this morning that the fact that there's 1 on 2 and 1 on 3 at the front of this thing might mean that we're integrating. So the first thing we considered doing was to integrate. So let's integrate. And when you integrate the left-hand side, you get x plus half n on 1 x squared. The half compensates for the x squared power, plus 1 on 3 n on 2 x cubed, plus 1 on n plus 1 n on n x to the n plus 1. Okay, so that's all good and well. That's the left-hand side when you integrate it. Now, when you integrate both sides, you're going to end up with a plus c somewhere, because you need to allow for the fact there's a constant, but you don't need a plus c on both sides, because that just confuses things. So, what do? Well, you integrate the right-hand side, and the integral of the right-hand side is equal to 1 on n plus 1, 1 plus x to the n plus 1 plus c. Okay, so that constant that's on the right hand side covers both the constants on both sides and becomes like one master constant. Okay, so all this is fine, only that we don't have what we want. Now we can get what we want, first off by substituting in x equals minus 1. So when we substitute in x equals minus 1, that works out nicely to allow us to find c. Okay, so c is equal to minus 1 plus half n on 1 plus a third, or minus a third, because of the minus 1 cubed. And then every time there is an even power, we're going to get a positive, and every time there's an odd power, we're going to get a negative, and that is summarized by minus 1 to the n, because when n is even, then we're going to get plus 1, and when n is odd, we're going to get negative. So it's minus 1 on n plus 1, n on n. Now that is lovely. On the right hand side we also get c, because the minus 1 subbed into the bracket on the right hand side makes the bracket 0. That makes all of that 0, and we just get c. So what we've done there is actually evaluate the constant. Now, that's not exactly what we were looking for. What we were looking for requires us to find the value of 1 minus half n on 1 plus a third n on 2, etc. So all we've done at the moment is evaluate c. So this is where it gets a bit interesting. Now the problem with that is that representing all of that in terms of c is messy. So I'm going to do another sub. I'm going to sub in x equals 0. When I sub in x equals 0, basically the whole left hand side disappears, because all the coefficients go to 0. So on the left hand side I get 0, and on the right hand side I get 1 to the power of n plus 1, I get 1 on n plus 1 plus c. So that's actually a much nicer version of how to find c than the first one. So I'm not going to use the first one to find c. I'm going to use the second one to find c, and that gives me c is equal to negative 1 on n plus 1. So now that leaves my integration expression, which is up here, as x plus half n on 1 x squared plus a third n on 2 x cubed plus 1 on n plus 1 n on n x to the n plus 1. That's my left hand side. And now on my right hand side I've got 1 on n plus 1 outside of 1 plus x to the n plus 1 minus 1 on n plus 1. So that's my expression now for the whole expression. In order to get what I need, now I need to be a bit more creative. And what I need to do is, to get my answer, I need the 1 on n plus 1. And this is where I'm going to sub in x minus 1. See, I think I actually subbed in previously x minus equals minus 1 too early. So I'm going to sub in x equals minus 1 into this expression here. And I get minus 1. That becomes plus half n on 1. That becomes minus a third n on 2 plus series, and this time I've got minus 1 to the n plus 1. Now we don't know if n is odd or even, so that's where I have to put in my minus 1 to the n over 1 on n plus 1 n on n. So that little minus 1 to the n there in the coefficient comes about because I don't know whether x to the n plus 1 is odd or even. If n is even, then I get x to the odd power, because it's n plus 1, which makes it minus 1. And that's the equivalent of writing minus 1 to the n. Because in minus 1 to the n, an even power will give you an odd answer, as it would. So it's a simpler way of expressing the exact same thing. On the right hand side, I'm subbing in 1 plus minus 1, which makes the first thing 0, and it makes the whole thing negative 1 on n plus 1. Now we got it close, but everything is actually reversed. So the final step in all of this is actually to multiply everything by negative 1. So I get 1 minus a half n on 1 plus a third n on 2 plus dot 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 dot. Now I'm left with an interesting power here which I need to consider. The right hand side is obviously 1 on n plus 1. We can see that all the terms that were previously positive become negative. And so the question is, have I done that correctly? So the answer is, with n even, have I done that wrong? Yeah, so the explanation I gave you before about making x to the n plus 1 equivalent to minus 1 to the n, that works for when x is equal to minus 1. So that expression is correct. In fact, this here, before you use x equals negative 1, should actually be that's correct. That should be like that. No, it should be negative there. And there's the solution. So to simplify, the first step is integration up the top here. The second step is to sub in x equals to 0. That allows us to evaluate the constant c. The third step is to substitute in x equals 1 to remove the right-hand side parts that we don't want, which enable us to evaluate the coefficients then on their own, and results in the expression as required. And that's it.